Namaste. I JVN Narendra Kumar Char, Assistant Professor in Department of Science and Technology under Faculty of Education and Methodology at Jyoti Vidyapith Women's University. Today we are going to discuss about secure sockets layer, that is SSL protocol. So when we talk about this, what is the SSL and TLS protocol? So when we talk about TLS, it is transport level security, transport layer security. So these are the protocols that are widely deployed and real-world security protocols that are used in the secure transactions in e-commerce, or we can say in the banking system. Now, what is the protocol analysis? Taking the case studies. Like first, we start with the RFC describing the protocol, and then we create an abstract model code. It up in merge and then specify security properties, and then run this protocol and whether security properties are satisfied or not. So this is for the SSL protocol and how we can design our protocol as well. So now what is SSL and TLS? So the transport layer security protocol version 1.0. So this is a standard for internet security. The primary goal is for TLS protocol is to provide the privacy and data integrity between two communicating applications. It's like there are two entities and they want to communicate, and the privacy and the data integrity must be ensured. So in practice, used to protect information transmission between browsers and web servers based on the SSL protocol version 3.0. This was the design. So the TLS 1.0 is basically the SSL 3.0. So same protocol design and different algorithms are there. So it is deployed in nearly every web browser. Now we see about the history of the protocol. So SSL 1.0 firstly introduced by the internal Netscape design, which was in 1994. So it was lost in the mist of time. Now the SSL 2.0 came in picture in the late 1994. So there were several problems in the SSL 2.0, which we will see in the next slides. And then SSL 3.0 was introduced. So this is also designed by Netscape, and Paul Kocher was involved in this. And in November 1996, the SSL 3.0 was launched. After that, TLS 1.0 was introduced in 1999. So it was not interoperable with SSL 3.0. See, the previous versions of SSL was interoperable with each other, just like they are successor of the previous protocol. Now we see the SSL 2.0 vulnerabilities. So there was a short key length. So in export weekend modes, the SSL 2.0 unnecessary weakness, the authentication keys that were it was only of 40 bits only. So it was easy to crack in just in few seconds, or if the resources are less than in just few minutes only. Second one was the weak MAC construction. So the message on authentication code was not that strong in that. Third, the message integrity vulnerability. So SSL 2.0 feeds padding bytes into the MAC in block cipher modes, but leaves the padding length unauthenticated. So this may allow active attacks to delete bytes from the end of the messages. And the last one was the CipherSuite rollback attack. So this was the attack on SSL 2.0. An active attacker may edits the list of CipherSuite preferences in the hello messages to invisibility force both endpoints to use weaker form encryption. Just like if there are two entities which are communicating, or they are established the connection at very first. So the first message is hello message. So in the hello message, it's directly can change the preferences, or the can use the CipherSuite. So the least common denominator, security and active attacks. So what is in the SSL and TLS? We can see in the diagram here. So the informal protocol description is here, formal protocol and individual model. So these are analyzed and to find the error. So here is the RFC which was requesting the comments from this protocol description here. When we see the request for comments, so the network protocols are defined in an RFC. TLS version 1.0 is described in RFC 2246. Intended to be self-contained define of the protocol that describes the protocol in sufficient detail for readers who will be implementing it and those who will be doing protocol analysis. Now we are doing the analysis, so it's about us. So the mixture of informal prose and pseudocode. Now we see the evolution of SSL and TLS at RFC. So SSL 2.0. So there were the page counts around 25. We can say between 20 and 30. And then the SSL 3.0, there was a page count of 60. Now in TLS 1, the page counts are 80 here. Next, we talk about the formal protocol. So what is the formal protocol? So when we design this, we design a protocol here. So we must keep things in mind like this must be secure and communication must be secure while handshaking or after the connection establishment, the data must be transferred securely. So TLS consists of two protocols. First one is the handshake and second one is the record protocol. So in the handshake protocol, it uses public key cryptography to establish a shared secret key between the client and the server. Just like we have discussed in the Diffie-Hellman key extension. So they have public and private keys individually, but they create a common shared key which will be used for the further communication here. Now use the secret key established in the handshake protocol to protect communication between the client and the server. So in the record protocol, we use the key which was generated in the handshake protocol, and then we communicate. We establish the communication between two entities here. Now we see the handshake protocol. What is the handshake protocol here? So there are two parties involved in this, or we can say there are two entities are there. The first one is the client and one is the server. So negotiate version of the protocol and the set of cryptographic algorithms to be used here in the handshake protocol. So interoperability between different implementations of the protocol. Now there is one more thing here: the authentication of client and server. So this is the optional. Like we want to authenticate our client or we want to authenticate our server. So just like in SSL, this was meant to authenticate the server by the client. But in TLS, this is optional. So use digital certificates to learn each other's public keys and verify each other's identity. So here we use the digital certificates and public infrastructure to authenticate our client or the server. Now use the public keys to establish the shared secret. First, we use the public keys to create a shared key, and after that, the communication happens. Just like here, we can see first a client hello message is sent here. Client hello message is sent here. Then it responds with server hello and with the certificate and server key exchange and certificate request and server hello done. So this is the complete message that server sends to the client. And here again, a client sends a certificate, a client key exchange, and certificate verify that the server certificate is verified, and this also sends a certificate. So here the communication is done. Now the client switch to the negotiated cipher finished, and server switch to the negotiated cipher finished. So this is the process where they both agree on the same point. Now we see basic cryptographic concepts. So what is the encryption scheme? So functions to encrypt and decrypt data and key generation algorithm. These are two involved in the public key cryptography. Secret key versus public key. So secret key, we can say there's a private key and public key is there. So there are two keys in a key pair of each entity. Secret keys must be kept secretly or must be kept privately, and public key will be delivered to the each entity or we can say each system in the network there. Now come to the hash function. So we are talking about the MAC message authentication code here. So MAC input to the short hash, ideally no collisions, and MAC keyed hash used for message integrity. It's like message must not be changed, but message will be delivered at its original state. Now the signature scheme. It's like to create a signature and verify the signature data. So what is the use of cryptography in this protocol? So there is a version, crypto choice, and nonce is there. So what is the nonce? Nonce is a number which is sent by the entities to exchange. Just like this will send the nonce like nonce minus one. So this is the mutual understanding that what will be the next number of that. We can say there will be a number only. So there can be something else also. So this ensures the freshness of message is like it is not expired or this is the fresh message is created right now here. Now server will send a version, a choice, and also a nonce in reply to this nonce. Signed certificate containing server's public key, that is KS. So we can say there is a public key of server that is named as KS. Now secret key is K here, encrypted with server's key KS. Again, shares of sequence of messages are exchanged between the client and server here. So this is the use of cryptography now. Now SSL and TLS cryptography is the key. So what is the public key encryption? So a key is chosen secretly, just like we talk about the handshake protocol, and key materials and encrypted with the public key. So when two entities want to communicate, if A want to send something to B, then it must use the public key of B here. Just because only B can decrypt it and see the message. Now we talk about the symmetric encryption. So the shared key encryption is of the data packets. So this is when we talk about the symmetric key, there must be a common key for each entity. So the encryption and decryption done by this the same key, but this key only lies within the A and B only. So no one knows about that. Now the third one is the signature-based authentication. So how signature-based authentication works? Client can check the signed server certificate and vice versa. It's like A can check B certificate and B can check A certificate. Now hash for the integrity of message. So a hash or a message digest is added to the message or the data we are sending here just to maintain the integrity, just like it is not changed anywhere. Now the client server check hash of sequence of messages and make it used in the data packets. Now when we talk about the public infrastructure, so this is there is a client and the server. They both have the public and private keys. A certificate authority is there. We can say this is the trusted authority here. So this ensures that the certificate of client and the certificate of server are valid. So these are signed and verified at each node. So the idea behind the SSL was just like to establish a connection first. So the first one, he sends a message just like hi, and in the response he receives the hello, and then he said the how are you. So here the connection is established, and here the communication is started. Now we talk more about the handshake protocol. So the handshake protocol may be executed in the abbreviation from to resume a previously established session. It's like no authentication, key material, no exchange. We already exchanged the keys, and there was a previous session. So based on that session, we just communicate to the entity. Now the session resumed from an old state. It is easy. For the complete analysis, have to model both full and abbreviated handshake protocol. So this is a common situation. Many protocols have several branches, sub-protocols, and for the error handling. Now the rational reconstruction. So begin with simple. So intuitive protocol. So they ignore client authentication first, ignore verification messages at the end of the handshake protocol. Model only essential parts of messages is like ignore padding, execute the model checker and find a bug. Add a piece of TLS to fix the bug and repeat. So to better understand the design of the protocol. So how we design a protocol here is like the first message will be the client hello here. So the client sends a message client hello, and then the server sends a message in the response. So it is plain text only. So it's a protocol working both client and server support. Strongest cryptographic suite selected from those offered by the client. So if a client suggested any suite that must be used in the communication, so this will be responded by the server. Next, server key exchange message is here. After that, abstract to the cryptography. So we use uh, we will use the abstract data types to model cryptographic operations. Like we assume that the cryptography is perfect, no details of the actual cryptographic schemes are there, and we ignore the bit length of the keys, random numbers, etc. What is the simple notation of signatures and hashes? It's like we write MK to denote the message. This is M is usually signed by K signature, and this is the hash of N. Now we talk about the client actions. So there will be a next message to the server here. Then the protocol is correct. The server share the same some secret key material, secret C at this point, and then the communication goes on. So when we talk about the finite state machines, so this is the complete process here at the client side and the server side. Just like first a client hello message is here, then server hello is here, then a server sends a key here, and then a client sends its key here, and it is done at the server side. Now, what is the intruder model here? Now we talk about the intruder. Intruders are those which may interrupt your network, or they can capture the network and then they do some malicious things. So what is in the cryptography? So there is no actual cryptography or model right here. So messages are marked as encrypted or signed. That's it. And the intruder rules respect these markers. It's like if he knows that this is the message that is encrypted, so it can see by decrypting it, but it cannot encrypt that again. And to the signed documents, it can see only. So our assumptions that the cryptography is perfect is reflected in the absence of certain intruder rules. So there is no rule for creating digital signature with a key that is known to the intruder, and there is no rule for reading the contents of a message which is marked as encrypted with certain key. When this key is not known as intruder, so there is no rule for reading the contents of hashed message also. So here is the analysis tool which is work on the formal protocol and intruder model both. So what is the basic SSL 3.0? When we talk about the suite SSL 3.0, so this is basically some info, with the improved security, just like some more things are added to it, just like nonces are there, and the secret key material also is there. So these are the things here. When the 2.0 fails to communicating, then we got the idea of the SSL 3.0 here. Now, when we see there is an attack on protocol P, so what is the thing we must add here? So we add the certificate security, certificate authority here. So that is the messages were signed by the certificate authority, and this only can be verified by the certificate authority only. So when an intruder goes there, so they will detect them. Now, what about designing your or protocol? So first we need to read and understand the protocol specifications that are typically in RFC, or we can see some research papers there. We will put a few on the website. We can see that. Now we have to choose a tool. So we can choose a tool there and start with simple a model, that is rational construction is a good way to go here. And what are some security goals, we have to define them, and then we test them with any of the tool, just like the secure a standard tool for security analysis of protocols is Avispa and Span, which is we have to code in the HLPSL, that is high level protocol specification language. Yeah. So this was all about the SSL and TLS. Thank you.